So when I say that we are demanding or we are targeting to get an optimum antenna structure, question is how to do that. I mean, how will we know that this is the precise dimension that we wish to work with? These are the types of components that we wish to incorporate in the structure. How will we know that? Generally, any project or in a larger sense, any development, research and development progresses through a few stages. First is, you need to decide upon what you want to get from the project. That means, what are your precise requirements in terms of antenna design, in terms of projects related to antennas. The basic thing that you wish to understand at the beginning, that what bandwidth you want to achieve. Even if precisely, I mean numerically you can't decide upon that, okay, this is the bandwidth, this much gigahertz or this much megahertz I want to achieve. At least you should be deciding upon that, okay, I want to work with or I want to develop a narrowband antenna or a wideband antenna or a multiband antenna, or basically mixture of a number of parameters. First of all, you have to decide upon that. After you decide your exact or approximate performance requirements, next you will have to choose the proper materials. I mean, if you want to design and develop a printed antenna, on what substrate, on what material you will cast the structure, that you have to decide, because different structures have different properties. After that, you need to make out what should be the dimension of the proposed antenna. Now here, getting the dimensions, or rather it will be better to say in this way, getting the optimized direction requires the process that we will be concentrating today in this project. This is nothing but simulation. Now, before I tell you about the intricate details of how simulation of antenna structures is performed, there might be a question arising in some of your minds that what exactly is simulation? I mean, we do say always that we are simulating a structure. Depending upon that simulation, we are basically developing a structure and further proceeding with the job at hand. What exactly is simulation? Simulation is nothing but plotting a graph. As simple as this. Simulation is nothing but, the outcome of simulation is nothing but plotting a graph. So how this is done? See, in our childhood, when we learned graphical analysis, we used to plot graph having 3 data sets, 3 sets of points, 4 sets of points, 5 sets of points, at most 10 sets of points, like that. Here what is done, we get, many number of points. It can go up to thousands, 10,000s, or maybe in some intricate simulations, it can go up to even 1 lakh, 1 million points. Now imagine dealing with about 1 million points, thousands of points, whatever, is a bit tough. I mean, from the ordinary knowledge of graphical plotting that we have, that is actually a bit tough. So normal process of graph plotting will not be sufficing to this requirement. So we have to use some modified, some advanced level of mathematical analysis. That is nothing but simulation. So simulation we can informally define in this way. It is basically, the outcome of any simulation is basically to obtain a pictorial representation. It can be a graph, it can be a pattern, 2D pattern, 3D pattern, whatever. It can be a distribution, a gradient distribution, whatever, where the number of points are very large. I mean, they can go up to the order of millions also. So that is simulation. So after we simulate, we will get a simulation result. And if we see that that particular simulation result is actually matching our requirement, is actually satisfying our requirement, we can go forward with the structure that is giving rise to that particular simulated results. So this is the importance, this is the significance of simulation in any real life project.